So we want to look at one more type of inequality, and essentially the idea is, again, in math, and I've mentioned this before, once you solve something, say we did linear equations, and then we did linear applications, and then there was absolutely nothing more to do with that, so what do? We jumped to quadratics. We did quadratic equations, then we did quadratic applications, and then there was nothing more to do with that. Now we're doing inequalities. We did the linear ones with only x, and those are boring, so what do you do now? Quadratic ones, raise the power of x. So, suppose we have this. X squared minus x is less than or equal to 6. And now the question becomes, how in the heck do I solve that? When they were linear, we essentially did all of the exact same algebra to solve a linear equation. We just had an inequality symbol in between them, right? Well, if that worked for linear ones, then we should probably maybe apply it the same here. If that's a quadratic one, what do you normally do to solve a quadratic equation? Huh? What's the first step to a quadratic? Set it equal to 0. Thank you. So set that equal to 0. And you get x squared minus x minus 6 is less than or equal to 0. Good. Well, then once we did that, generally speaking, the next step would be what? Factor it. Because all of you can factor this, because at this point we've done it like 12 times this semester. It's the easiest one I can come up with. Two numbers, product of negative 6, sum of negative 1. X minus 3, x plus 2 is less than or equal to 0. And of course from there, if this was an equation, the next step would be to solve these and get x equals 3 and x equals negative 2. Correct? And if this was an equation, we'd be done. We found our two solutions. We want this where it's equal, because it's less than or equal to, so technically those are some of the solutions. But we realize there's actually a whole lot more of them now, right? Because it's an inequality. And we have to find those. And there's a trick to this, which can be somewhat confusing. It's actually a standard math trick that pops up a lot. I'm going to use it later in my calculus classes for more complex stuff. But it tends to confuse people unless you kind of understand what's going on. That's quadratic, right? What's a graph for quadratic look like?
Parabola.
Parabola. We have done this repeatedly, which means the graph, we haven't covered this yet, but this parabola, they can be upwards or downwards, look like a U or look like an N. That's 1, so it's going to go upwards, which means this thing looks something like that right there. Just trust me on that for now, it's not a big deal. It doesn't really matter. You want to know, according to this, where that quadratic is less than or equal to 0. Where is it less than or equal to 0?
3 and
Well, in this context, everywhere in it, right? Without the graph, how do we algebraically test that? And there's this trick here. Going into the math of it is not all that important because it's pretty understandable. That's a continuous function, which I'm assuming at some point you guys have covered continuous functions in your high school classes. There's a really important mathematical definition for it, which we don't really need. Essentially, a function is continuous if you can draw it without having your pencil leave the paper. Meaning, done. So that's continuous, and that's it. And once it's continuous, there's a whole lot of properties it gets. And essentially, if I pick a number, say right here, and then I plug that number into the function, I get that number down there, which is negative. If I pick some other number in this interval, say right here, I plug it into the function, I get negative. If I pick some third number out here, plug it into the function, I get positive. Kind of see what's going on here? Essentially, the short form, the short idea here is, for any interval around these zeros right here, pick one number in that interval. If the function value of that number is positive, then every number in that interval is positive. If the function value is negative, every number in that interval is negative. I mean, when you look at it, it's pretty obvious to see, right? If I pick this x right here, that gives me a positive value. If I pick any x in this interval, will the function value be positive or negative? Positive, because it's going up. It's continuous, it has to keep going up. So once I know one point in there gives me a positive value, I know every point in there gives me a positive value. If I know one point in there gives me a negative value, every point in there gives me a negative value. To solve the inequality, I want to know where it's negative, which means I just need to find the intervals where the function is negative. To do that, you use what's called a sign chart. This is actually the really useful math thing that we use a lot that just tends to confuse people. All you do is draw a number line, list out your zeros. Those are what break up your interval. So in this case, we have -2 and +3. Pick a point in each interval there. There's 3 of them. You can all see that. Pick a point in each interval and plug it into your function. All we care about is it positive or negative? Sign chart, the sign of your solution. So over here, you can pick any number you want. I'll pick -3 because it's the smallest one over there that's nice and round. Plug it into here. Actually, make it easier. Plug it into the factored thing. If you plug in -3, -3 minus 3 is -6. -3 plus 2 is -1. What's -6 times -1?
Positive
6, which is positive. So this interval is all positive. In here, between -2 and 3, pick 0, because, it's 0. Plug it in. 0 minus 3 is -3. 0 plus 2 is 2. -3 plus 2 is -6. And again, all we care about is negative. Pick something greater than 3. Might as well go with 4. 4 minus 3 is 1. 4 plus 2 is 6. 1 times 6 is 6. Positive. So where are my solutions? I want where it's less than or equal to 0. It's negative right in there. So my answer would be what? -2 to 3. This thing, you're going to have to write an interval notation. Do you all know how to write interval notation? Yes, no? Not really sure? Okay, we're going on the interval from -2 to 3. The only thing that really matters is what I put around them. And essentially, if it's a strict inequality, greater than or less than, you put parentheses. If it's a non-strict inequality, less than or equal to, greater than or equal to, put in brackets. Essentially, that's the way we say that we're including the endpoints with this one, but not with parentheses. Got it? Think you can work through all that? Okay, we're going to do one more. Then we'll be good. So let's see, we have time? Oh yeah, we have plenty of time. It's fun. So suppose we have x squared plus 13x is plus 30 is greater than 0. We'll already set this one to 0 just to be good. Again, you all know once it's quadratic, first step is always set to 0, right? Now solve that. Treat it like a quadratic, so factor it. 2 numbers whose product is 30, whose sum is 13. We've done this one like 5 times 2. 10 and 3. So we get x plus 10 times x plus 3. Now from there, find my zeros, right? Just switch the signs. We get x equals -10 and x equals -3. Now that I have my zeros, we get to do the inequality stuff, so create a sign chart, right? So let's see. Put in my zeros. So I guess negative 10 is first because it's smaller than negative 3. And now plug in points. Let's see, that's negative 10, something to the left of that. Go with negative 11. You can use whatever number you want. I generally just pick the closest, easiest whole number to work with. It doesn't matter, you have calculators, do whatever you want. You plug in negative 11. Negative 11 plus 10 is negative 1. Negative 11 plus 3 is negative 8. Negative 1 times negative 8 is positive 8. All we care about is the sign, so it's positive. Negative 10 to negative 3, go with negative 4. If you plug in negative 4, negative 4 plus 10 is 10 minus 4, 6. Negative 4 plus 3 is negative 1. 6 times negative 1, negative 6. So this is negative. Over here, go easy on yourself, use 0. 0 plus 10 is 10, 0 plus 3 is 3, 10 times 3 is 30. So this one's positive. I want where this thing is greater than 0, which means I want this interval and this interval. The difference here that now we have 2 intervals, not 1, right? There are different ways to write them. Sometimes people have you write them with unions and intersections. People done that before? I tend to think that is an important mathematical thing to know, and I know how to do it, and I use it, and it's pretty much a useless skill for you guys that you will never see again at any point in your lifetime. So I don't really want to take the time to go over an intersection and a union and what they mean and how to write them. You have 2 intervals here. You're in this one or this one, so just write that. For this interval, you start on the left, which is negative infinity. You are all aware that negative infinity is over here and positive infinity is over there, correct? So since we want everything to the left, we start at negative infinity. We end at this endpoint, negative 10. Parenthesis or bracket?
Parenthesis.
In this case, this is a strict inequality. We're not including the endpoint, so we write a parenthesis, an open set in math speed. Or, that's a cursive R. We want this interval. We're starting at negative 3. So negative 3, and we go out to infinity. And we're done. And again, that's a parenthesis, because there's still a strict inequality. Get the idea? Okay, let's see. Yes, we'll be good.